Hi, I'm Libby.
I'm Anna.
And I'm Kate. Today we are going to be discussing kinematics through the use of a clip from Disney's cartoons.
In this clip, Mater, a tow truck, speeds up to jump off of a ramp, but he ends up not gaining any distance at all.
Using kinematics, we will find out how accurate the scene is or how far Mater should have actually flown.
Here we see Mater backing up in order to get distance from the ramp in order to gain speed. Now as he speeds up, we will see if he can clear the trucks. Which he does not, and falls very short.
Coming through, good to see you. My bad. Hey, Ricky, how's the kid? Watch your hood.
In order to analyze the clip, we first need to talk about kinematics and projectile motion. Kinematics is, in the most basic sense, looking at the features of motion of an object. Projectile motion is more specifically what happens when an object is in motion near the surface of the Earth, under the constant force of gravity. There is no acceleration in the x direction. This is because there is no force acting in that direction. Since there is no force acting in the x direction, the x component of the velocity remains the same for the entirety of the launch. The only force acting on the ball is gravity, which is in the y direction. This is what makes the ball fall to the ground. These are the equations that we will be using in order to calculate the distance Mater should have flown. Delta x equals v naught x times t, and delta y equals v naught y times t plus 1/2 at squared. These are what the variables all mean. Now that we have our equations, we need to determine what we need to estimate from the video. From just watching the clip, we can estimate Mater's speed off the ramp, how far the second ramp is, and the angle of the ramp. First, we can estimate the angle of the ramp. We estimated this to be about 20 degrees. Next, we will be calculating the distance between the two ramps. In order to do this, we first need to estimate a few things based off of the clip. In order to estimate the distance between the two ramps, we assume that the average width of a car is 1.8 meters. Here, we count 36 cars. Since we have counted 36 cars between the ramps, we know that the distance between the ramps is 1.8 meters times 36 cars, which is 64.8 meters. We estimated from the video that the distance Mater backs up is around 225 meters. Now we must calculate the velocity when he goes onto the ramp. Velocity is measured as the distance over time, and since the distance before the ramp is 225 meters, and he took about 9 seconds to get there, the initial velocity is 225 meters divided by 9 seconds, which is 25 meters per second. Now that we know the initial velocity, and with estimating the ramp is 20 degrees, we can find out what the velocity in the x and y directions are using trigonometry. Therefore, to solve for the horizontal component, we can use the equation v initial x equals 25 times cosine 20 degrees, which gives us 23.5 meters per second. Similarly, we can use v initial y equals 25 times sine 20 degrees, which gives us 8.6 meters per second. If we say that the top of the ramp is y initial equals 0, then y final would be where he lands on the cars, which we can estimate to be 1.4 meters below the top of the ramp. This means that delta y equals negative 1.4 meters. This leaves only time as the unknown. We can solve for time by using this projectile motion equation in the y direction. We plug these numbers into our equation and use the quadratic formula to get t, which we find to be 1.85 seconds. Since we now have time, we can go back to our original equation in the horizontal direction. 1.85 seconds times 23.5 meters per second gives us 43.4 meters. Therefore, the change in the x direction is 43.4 meters, which is the same as him jumping past around 24 cars.
This proves that this clip is impossible in the real world of physics, because in the clip we see Mater fall straight down. In reality, he would make it about 2/3 of the way.
Now we have a question for you.
What is the initial velocity that Mater would need to make it across all 36 cars?